physics informed neural network. So before that, you have already understand what is artificial neural network. This part we have completed, and on the first day I told you that if we add physics to it, so this become physics informed neural network. So we have to solve PDE or ODE or any research related problem which has some physical phenomena, and you can convert that physical phenomena to mathematical equations that can be solved with the physics informed neural network. So I will start from one of the problem, 1D heat problem. This is parabolic differential equation. We will take one of particular one-dimensional diffusion or heat problem. So this is our problem, partial u over partial t. Here we have some kappa, partial 2u over partial x square, and in one dimensional we are taking length, 1 unit length, and we should have some initial condition. So u at x0 is following this law, sine pi x. So this is the initial condition. And then we have boundary condition. So on 0t, on the left side, uh, left boundary condition or the right boundary, both are 0. Okay, you can just write this one is 0. Simple problem. So if you observe, what is this? This is a unit length rod because it is a one dimensional, so there is no width. Okay, this is a rod, its length is 1 unit. On the left boundary here, there is no temperature 0. On the right boundary at 1, also no temperature 0. And at time 0, the temperature follow this sine function information, sine pi x, whatever the point. This is at the time 0. Okay. Now we have to solve this one with the artificial neural network. So first question, the artificial neural network predict the correct answer or approximate answer? Approximate answer. And approximate answer we can also find with the help of numerical method. So we have to work or think like we are solving the equation like a numerical method. Okay. So what you do? This is our physics that at time 0, the temperature is following this information, sine pi x, and we want to find that at time 0.5, what will be the temperature on this grid from 0 to 1? This is our target at 0.5. So if you know some idea of the numerical method, any numerical method, in numerical method, what we do, we discretize the domain. Okay. So here We can also discretize the domain. For example, I can take in x direction, delta x equal 0.2. So next point will be 0.2, then we have 0.4, 0.6, 0.8, and finally we reach to 1. Same we can do in y direction, that is a time direction here, because we have to reach, this is a grid, this is not the time. You may say this is the information at time 0 and you need the information at time 0.5. Okay. So if I say delta t is 0.1, so next, this is 0, this is 0.1, this is 0.2, 0.3, and 0.4, 0.4 and 0.5. So in any numerical method, mostly if we apply any explicit method, we have time 0 information, we have everything at time 0. We first catch at time 0.1 information at all points, whatever. For example, here we have anterior point, 4 anterior points. So we try to find the information at 4 anterior point at time 0.1, then move to 0.2, then 0.3, step by step, then move to 0.5, and finally we reach to 0.5. So this is the problem physics. I know what I need. If I don't know what I have to calculate, I cannot design accurate this one. So in my problem, the equation follow a heat law. On the left boundary, no temperature. On the right boundary, no temperature. But the temperature at time 0 is given at these points. For example, if I discretize only 4 points, okay, I know what is the temperature at time 0 at this. How can I calculate? I will plug here. So x is 0 here, sorry, time is 0 here, and x point is 0.2. So I will plug here sine pi and 0.2, whatever the number. I know the initial temperature. Similarly, I know the initial temperature at 0.4, 6, and 8 by this law. Now my target to find, for example, I have only 4 these anterior points. At this particular point, I need a temperature here. At this particular point, I need, at these 4 points, I need a temperature with the help of physics informed neural network. So I know the domain of my problem, I know the physical law of my problem, and I know what is the target. Okay. So I will pick one of the artificial neural network. So to explain you, I will start with the very simple neural network. After that, you can generalize. You know how to generalize the neural network also on the Python. So what neural network I am choosing? I have only 3 neuron in the layer 1 and 1 neuron in the second layer. Here I have to input my information here. After that, after this machine or artificial neural network, I will get my output. So in our problem, everyone know what will be the output. The output is this u variable. Okay. U variable is depending on x and t. So output will be x and t. So what will be input? X and t, x and t. Okay. But your target to find the output only at these points. Okay. If I use the same discretization, So this point is 0.2 comma 0.1. Similarly, all other point. What is this point component? This will be 0.8, 0.5. So how many X and T you have, or how many pair you have, if you just use this grid to solve your problem? You have 4 in this layer, 8, 12, 15, and 20. In numerical method, we say anterior point. Here we say collocation point. So these are called collocation or anterior points. So I have 20 anterior or collocation points. This I have designed. It is up to you. You may use 1000 collocation points. I am just explaining you. This way it will work. Okay. So it's mean you have 20 samples of X and T pair. This is X and T pair. This is X and T pair. So what you need, you have to pass each sample from this neural network one by one. This is called batch input. This is why I explained you first day how batch work, how batch information pass from one neuron to other neuron. ओ इम्तियाज जवेद को बुला के लाओ ये फिक्स नहीं होगा. So I have a vector uh, 0.2, 0.6, 0.8, and sorry, 4, 6, and 8. This is the x vector. And what is the t vector? T vector is 0.1, 0.2, 0.3, 0.4, and finally 0.5. So when I make samples, so they total become 20. These are our total points. So you will pass 1 point from this one. Your artificial neural network gives you the value on that particular point. Okay. In numerical, we say match point also. Then you second, then you third, and so on. Once you complete the batch, after that, you will check your loss. I am coming to loss after that. If your answer is correct, you will stop. If answer is not correct, what we will do? We will go for back propagation. After plugging 20 point one by one in the same neural network. Then we do for back propagation and update our parameter with the help of any optimizer. Okay. At the initial stage, we may use gradient descent or little better is Adam. Okay. So this will be the mechanism. So one collocation point come from here, passes through and give you the value. So after a batch, your U is also a vector of 20 by 1. Okay. Because total points are 20. And here you have X and T, a sample. First point, for example, you have 0.2 comma 0.1. It is up to your sampling. Second point 0.2 comma, you may use this way. You may pass the match point one by one horizontally. You can also vertically. It is up to you, your sampling. Second point may be 0.4 comma 0.1 and so on, total 20. This also has length 20 into 1. So on 20 match point, you will have 20 outputs. Okay. So here I am using tanh hyperbolic as an activation function. I told you why we use in PD tanh hyperbolic. We need more smooth. No, it's okay. So For this one, you can use any activation function, but for the final output, you can also remove it for physics informed neural network. Why? That activation function, they have some range. Some are between -1 and 1. For example, 10 is between -1 and 1. If I plug 10 here, activation function for my final layer, you always have value between -1 and 1. But we don't want between minus and 1 for our heat problem. We want it between minus infinity and infinity. That's why for physics related problem, you can skip the last neuron activation function. You can make it free that you want answer between on the whole real line, minus infinity to infinity. So right now I will not use this one. Clear why I am not using activation function for my last neuron? Because I want a free answer. Already I have 10 here for the first one that automatically make it non-linear after the first layer. And when we generalize it, there are so many 10 before the last neuron. So no need to put here. So what happened? You have X come here, you have T come here. This one has some bias, let's say B1, B2, and B3 are the biases here, and it has bias 4. It has where W11, W12, let's say W21, W22, W31, W32. So what will be the output here if X is coming and T is coming as an input? So let's say S1, it will be W11X plus W12T plus B1. This is the output of this neuron before the 10 plus B1. And for this one, S2, the neuron, this is neuron output, W21X plus W22T plus, let me make it here, W22T plus B2. This is the output of this neuron. This is the output of this neuron. And for this one, S3, W31X plus W32T plus B3. Then they have to pass from this tanh hyperbolic. Let me extend it. So I am saying A1. A1 is tanh hyperbolic of S1. A2 is tanh hyperbolic of S2. A3 is tanh hyperbolic of S3. Then they reach to this final neuron. So our it has B4. So our UXT is finally it has its own weight V1, V2, let's say V3. V1 A1 plus V2 A2 plus V3 A3 and plus its bias B4. So this is our final output with the help of X and T passing through this machine. So if this information is correct, this you have to pass for 20 points. Here I am using one symbol only. First match will come, then second match will come because complete batch has to pass. Because total samples are 20. For our problem, 20 sample will pass, sample of X and Y passes through this, and you will give you a 20 value for U. Okay. If these 20 values are correct, what you do? You will stop this one if these 20 values are correct. Okay. If these 20 values are not correct, how you will check they are correct or not? How do we have target value? So here we will plug in here because these are the value of u. You will plug in this equation. For example, you don't have artificial neural network, you have any method. You get the values of u. You want to check whether these values are correct or not. That equation, if that equation justified or satisfied, so it's mean those values are correct. So here come laws of physics informed neural network. This is a particular type loss. It depends upon the physics. This is equation. So right now our loss will be this one. Partial u, partial t. You will shift all the data on one side. Kappa, partial 2u, partial x square. What is will be on the right side if I shift all the data on the left side? Zero. So, and I need mean square. So you will divide it by n. And what is n here? For our problem, 20. Length of the vector. Okay. So this is a new thing. This only in physics informed neural network. So we are adding the physics of our problem inside the loss function. That's why they call physics informed neural network. So how do you calculate if this loss not equal to zero? We will have to go for the second time. Same 20 point we have to pass. So what we do? We will do back propagation. Okay. So in the back propagation, you will update these weights and these biases. So these are 6, 7, 8, 9, and these are also weight 10, 11, 12, and this bias 13. Total 13 weights and biases you have to update. So let me to recall that one. I will write the expression for one of the weight. So I am writing for W11 partial L. This is the loss and partial W11. So if you go backward, here you have U. Okay. So do we have these things? Because in the loss we need this one. Do we have this information from the neural network or not? We have only this information. This is just u. We don't have the derivative of these u. With respect to x or with respect to y, we don't have the second derivative, which we need here. So before calculating this one, you should have these derivatives. There are different way to catch these one. Okay. So one way, this is also a back propagation type chain rule. You will calculate it. How? You have your u value. Okay. This u. And what is that u? That is v1 a1 plus v2 a2 plus v3 a3 and plus v4. I need this derivative partial u over partial t. So this will be v is a number v1 partial a1 over t plus v2 partial a2 over t plus v3 partial a3 over t, and this is also a constant. When you find the derivative, that's become automatically 0. And if you observe, what is this? This is exactly partial over partial t. This is a hyperbolic function, tan hyperbolic, and inside it has s1 plus v2 partial tan hyperbolic s2 over t plus v3 partial tan hyperbolic s3 over partial t. So what is the derivative of tan hyperbolic? Secant square. Okay. And we don't have a secant information. We can again convert it to back because 1 minus tan hyperbolic is also equal to hyperbolic square, secant hyperbolic square. So we use this identity. So the derivative of this one will be 1 minus tan hyperbolic square s1. Then inside function derivative with respect to t, s1. What is the derivative of t? W12. Then similar for the second equation v2 1 minus tan hyperbolic square s2. Here you will get W22. Yes, from here W22. And for the third term, you will get V3 1 minus tan hyperbolic square S3 and W32. So this expression will give you the partial derivative of of u with respect to t. And then you need the second derivative of the u with respect to x. So first you calculate the first derivative, same way. This is your u from the u. Then from that you can reach to the second derivative. I am not calculating. I explain you the procedure. This is the procedure. We first have ux, and from this u, you will get your second derivative ux square. Once you have these information and kappa is the parameter, then you plug here. Okay. Then you have a loss function. Then you check whether loss is equal to 0 or not. This is not a simple loss. This is a physics related loss. And it has a particular name. We call it PDE loss. There are other loss also. Okay. So first calculate the loss, and for the loss you need the derivative. Okay. But in Python, this we can also do by autograd. Okay. But you should know these we need. So physics informed neural network is different from artificial neural network, especially for this reason. Okay. There is a physics related loss. Once we have this information, let me say this expression or this complete expression is equal to R because we have this information. Then you calculate the derivative of your weight function. So let's do one calculation for this one. Partial loss over what is the last output uh, from the loss. Here you have loss and you will go back here A1. This path is going back to W11. So you will have A1, and from A1, this is you will reach to S1, and from S1 you will reach to your W11. Okay, and this is the tan hyperbolic derivative. And if you observe from this one, this is just x only x. Okay, this is x. This is tan hyperbolic derivative with this S1, and this is from the loss. If loss value, loss is not easy, a complicated expression. If loss value you say it is R, So whatever the expression you have to calculate from, let me say, r derivative of this one. So after getting all the weights and biases derivative, you can update them. W11 new value will be equal to W11 old value minus learning parameter and partial of the derivative. This one, this is a gradient descent. Or you can also use Adam. I told you what is Adam. You just tune some information here or the न्यूरल नेटवर्क में हमने एक टैन फंक्शन यूज कर लिया है। फर्स्ट लेयर के बाद टैन किया, वो उसको नॉन लीनियर बना देगा उस इंफॉर्मेशन को। और ये बिल्कुल सिंपल न्यूरल नेटवर्क है, ये कभी भी इस इक्वेशन को सॉल्व नहीं कर सकता। ये बिल्कुल 2-3 साल के बच्चे का ब्रेन है, ठीक है, इतने से न्यूरॉन होंगे उसमें। उसको हमारे जैसा ब्रेन चाहिए, मिलियंस ऑफ न्यूरॉन। और क्योंकि मैंने डिजाइन किया है तो बता देता हूँ, आपको कम से कम 64 न्यूरॉन की 3 लेयर्स चाहिए, फिर ये डायरेक्ट आंसर कैलकुलेट होगा, अदरवाइज नहीं होगा। 64 की 3 हिडन लेयर और उनके दरमियान 10 हाइपरबोलिक, और कम से कम 5000 दफा ई पोच करनी पड़ेगी, फिर सही आंसर के करीब पहुंचोगे आप। ठीक है, तो ये नहीं कि यही कर देगा, ये इसलिए समझा रहा हूं कि वर्क ऐसे ही करेगा वो भी। ठीक है, इससे पहले लास्ट लेक्चर में समझा चुका हूं कि इसको एक्सटेंड कैसे करना है दोनों डायरेक्शन में, इस डायरेक्शन में और न्यूरॉन की डायरेक्शन। हाँ, अब मैंने मैनुअली सारा बताया कि ऐसे वर्क करना है इसने। ठीक है, अगर हम मैनुअली कोड डिजाइन करेंगे बहुत लेंथी और कॉम्प्लिकेटिव होगा, इसलिए कल जो था यस्टरडे को मैंने स्मार्ट कोड लिखने का तरीका बता दिया था कि सारे डेरिवेटिव एक कमांड से होते हैं। क्या थी कमांड? लॉस डॉट बैकवर्ड। आपने टॉर्च लाइब्रेरी के ऊपर लिखनी, इंपोर्ट करनी है, और सिर्फ लिख देना ट्रेनिंग के अंदर जाके लॉस डॉट बैकवर्ड। ये सारे डेरिवेटिव जो भी है, जिसका डेरिवेटिव उसको पता है वो कैलकुलेट कर लेगा और सही जगह पहुंचा भी देगा। क्लियर? लेकिन वर्क कैसे करेगा कि आपको फिजिक्स इन फॉर्म का पता होना चाहिए कि इनपुट कैसे होती है। इनपुट ये नहीं कि पूरा डब्बा भर के सारे डाल दिए इसमें, एक एक मैच जाता है हर दफा। ठीक है, आपने जितने मैच किए हैं और 20 मैच या कोलोकेशन पॉइंट करेंगे तब भी, चाहे बहुत बड़ा न्यूरल नेटवर्क, तब भी वो कैच नहीं कर सकेगा इस फिनोमिना को। इसको भी कम से कम 500-600 पॉइंट चाहिए इसको कैच करने के लिए सही तरह। तो ये जो फिजिक्स है ना, इसकी उसकी भी इंपॉर्टेंस है इसमें, कि आपको कम से कम 500 इंटीरियर पॉइंट चाहिए सही आंसर के लिए। ठीक है, और दूसरा यहाँ पे बेनिफिट है या थोड़ा चेंज है, ये जो न्यूमेरिकल मेथड होता है ना उसमें इसी तरह का ग्रिड होता है, आप चलते हो। जो न्यूरल नेटवर्क होता है उसमें आप रैंडमली भी इसको कर सकते हो। और फॉर एग्जांपल अगर मैंने यही मैच बनाए हैं टोटल 20, जरूरी नहीं है कि 20 ही आपने पास करने हैं। आप 20 से कम भी पास करो, उसमें कैपेसिटी होती है, वो ऑब्जर्व कर लेता है फिनोमिना को। मैं 10 मैच पॉइंट दे के भी उससे ये काम करवा सकता हूँ। एग्जाम्पल दे रहा हूँ, 10 से नहीं होगा। फॉर एग्जाम्पल मेरी असली प्रॉब्लम में 1000 के करीब या 2000 के करीब मैच पॉइंट बन रहे हैं, तो मैं 2000 नहीं दूंगा, वो कंप्यूटेशनली कॉस्ट हो जाएगी ना, टाइम बचाने के लिए मैं ये आधे दे दूंगा उसको, तब भी वो फिनोमिना को कैच कर लेगा। ठीक है, तो ये है, ये फिजिक्स समझ आ गई है, अब इसको इम्प्लीमेंट करना है बस हमने। सॉरी, हाँ नहीं, यही बता रहा हूं, जो बैकहैंड पे वर्क हो रहा होता है, ये पूरा बैच बनता है ना, बैच इसी को हम कहते हैं कि ये पेयर बन रहे हैं, एक पेयर, दो पेयर, टोटल 20 पेयर हैं। ठीक है, न्यूरल नेटवर्क में जाने हैं। लेकिन आपको पता है जब नेक्स्ट टाइम न्यूरल नेटवर्क ने आना होता है सेकेंडरी पोच के लिए, उसने अपडेट करना होते हैं अपने पैरामीटर्स को। तो ये नहीं वो करता कि एक मैच पॉइंट को इनपुट किया वो अपडेट कर ले वापस आ जाए। वो पूरे सारा बैच जाएगा, कंप्लीट हो जाएगा, फिर वो अपडेशन की तरफ आएगा। ये समझा रहा हूँ, इसका मैकेनिज्म ये होता है। ठीक है, और कोई क्वेश्चन? एक मिनट।